All right, so no homework questions. Last day of notes, and we'll be doing more radical equations, okay? So let's do a little bit of an application problem here. It says the water line length of a sailboat is the length of the line made by the water's edge when the boat is full. So let's say this boat is full. The water line length is where that boat meets the water line. Is that okay for everybody? Okay. A sailboat's hull speed is the fastest speed that it can travel. You can estimate the hull speed, h, by using that formula. Does everybody see that formula? What do you notice is in that formula? L for length, right? What is L representing? Length of the sailboat's waterline. We all good? All right, we are sailing in a friend's sailboat. They measure the hull speed at 9 nautical miles per hour. Which variable is that? H. So where do you think I should put that 9? In the beginning. It says find the length of the sailboat's waterline. What represents the waterline? L. So I got to find L, right? Means I got to isolate L. How am I going to do that? Are we going to minus it? Divide it. See, everybody see how this is being multiplied? So we're going to divide it. Now I'm sure this is going to end up being a decimal, but that's okay. Can somebody give me that measurement, please? Like that? Okay, so now how am I going to get the radical off of there? Square it. So that gives me L equals, now my directions say round to the nearest foot, which means I want a whole number. 45? 45 what? Length is in, well, they say feet or foot, so yep, feet it is. Good. Take what you know, plug it in, solve it. Any questions on that? Okay. Number 2, the equation v equals the square root of 2.5r represents the maximum velocity that a car can travel safely on an unbanked curve. Does everybody know what banked and unbanked means? What is a banked curve? It's like goes up. Race cars, NASCAR, right? They have banked curves. These are unbanked, meaning, where's a curve around here? Oh, right out here. Martin Moline has a curve on it, right? That's just a flat curve, right? Not banked. That's what we're talking about here. When v is the maximum velocity in miles per hour and r is the radius of the turn in feet. If a road is designed for a maximum speed of 65 miles per hour, let's stop right there. Which variable is 65 miles per hour going to go in for? V for velocity. What is the radius of the turn? What variable is radius? So I got to isolate the r. How do I do that? I'm going to square it first. Does everybody see how the 2.5 is inside? Okay, so we're going to square it. Can you go ahead and square that 65 for me? Say it again. Like that. And then now we have no more radical. So now how am I going to isolate the r? So r is 1,690. And this is radius. What are we measuring the radius in? Feet. Right? See how it says the radius in feet? There we go. Looking great. Everybody okay? All right. An object is dropped from an unknown height and reaches the ground in 5 seconds. Use the equation t equals the square root of h over 4, where t is the time in seconds and h is the height in feet, to find the height from which the object was dropped. 5 seconds is what variable? T. So I'm going to put that in where the t is. They want me to find the height. What variable is the height? So I got to solve for h. What are you going to do first? Yep. That 4 is on the outside. And then? It's all right. I knew what you meant. 400 is h. 400 what? Height in feet. Perfect. Is that my last one? Okay, on to our notes for today. All right. You all know that day 2 normally gets a little harder than day 1, right? Okay, so let's fill in some blanks here. What are radical equations? What's another word for radical? Square root, right? Equation with a square root. Bless you. Equation with a square root. Yesterday, for us, we had one type of variable. When you have one type of variable, all you have to do is what? You have to isolate it. And when you are isolating that radical, how do you then get rid of the radical? Square it. The opposite of the radical is to square it. So you would have yesterday squared both sides. Everybody okay here? Okay, so new portion today. When there are variables on both sides of the equation, so flip your paper over and take a look at those equations. You all see how there's variables on both sides? Yes, so that's the new stuff today. When there are variables on both sides of the equation, when you square each side, you must check for extraneous solutions. Now that's a big word, right? Extraneous solutions are solutions that don't actually work. Meaning they're not really solutions, are they? You remember yesterday how I had you plug them in and check a couple of them? We're going to have to do that for all of them today. Okay. These are solutions that do not actually work. The only time you have to do this, folks, is when you have variables on both sides of the equation. So, all of them today. Okay? Everybody good? All right, so let's try. Let's start with number 1. Is the radical isolated? Is there anything outside of the radical that we need to move? No. So how am I going to get rid of the radical? I'm going to square it. Now, I have to square both sides. Does everybody see that? Now, over here, it's just going to be a k plus 1 because the radical disappears. But this right here is a binomial. How do I square a binomial? Write it twice. Chop it in half. You got it. So I'm going to have to write this thing twice. Everybody see that okay? And now I'm going to have to chop it in half. What will it look like when I chop this in half to multiply? Now remember, folks, when we say chop it in half, you are literally cutting this first one down the middle. And you are taking the k and distributing it to the second parentheses and the minus 1 and distributing it to the parentheses. Let's multiply now. What is k times k? What's k times negative 1? What is negative 1 times k? And negative 1 times negative 1? Positive 1. If you put your like terms together, I get k squared minus 2k plus 1. How's everybody doing? Just fine? Now, this other side over here is still there, right? Yeah. So, do you have one type of variable or two types of variables? You have two. You've got a k squared and a k, don't you? Which means you got to set it equal to 0 and solve. So, what are we going to move? Would you rather move 3 things or move 2 things? I'd rather move 2 things. So how am I going to move that k over? I'm going to subtract the k, and I'm going to put that underneath the k over here. How am I going to move this plus 1? Minus 1, also underneath the 1 over there. These now cancel, and I have 0 equals k squared. What is negative 2k minus k? Negative 3k. And how about plus 1 minus 1? Gone. So that's what I'm looking at. Now that I have this set equal to 0, I need to factor it. What's the first thing you look for when factoring? Oh boy, you got to go back. Think. What's the first thing we look for when factoring? Okay, what do they have in common? A k. So I can factor out a k. What's left? Everybody good with this? Do I have any more squareds left in there? Which means I can't factor it any further. Which means now you need to tell me my answers. What answer does this give me? 0, right? What answer does this give me? 3. So I got to figure out which one of those don't work, because one of them is extraneous. So we're going to plug it in. Do you want to try 0 first or 3 first? 3? All right, here we go. If I put a 3 in up here, what's 3 plus 1? What's the square root of 4? 2. Everybody good with getting a 2 on that side? If I put a 3 in here, what's 3 minus 1? Does 2 equal 2? So this one works, doesn't it? Which means this one probably doesn't, but we're going to check it anyways. If I put a 0 up there, what's 0 plus 1? Square root of 1 is 1. So that left-hand side is a 1. If I put a 0 on the right-hand side, what is 0 minus 1? Negative 1. Do they equal each other? Does 1 equal negative 1? So that's the extraneous solution. The only answer that will actually work here is 3. A little bit more work to be done there, isn't there? A little bit of time. Let's try again. Let's look at number 2. Do you have anything outside of that radical that needs to be moved? Everything's on the other side, right? So how am I going to get rid of the radical? We're going to square both sides. So when I square this side over here, it just gets rid of the radical. When I square that other side, that's a binomial. How do I square a binomial? Right. Yep, you're right. Write it twice. And then once I write it twice, what do I need to do next? Not break it down. You're going to cut it in half and distribute. What will it look like when you cut it in half? Everybody following William? You sure? Distribute. T times T. T times 3. 3 times T. And 3 times 3. If I put those together, I get a 6T in the middle. And I'm going to bring down that other side. How many kinds of variables do I have here? 2. I've got a T squared and a T, don't I? Which means I got to set it equal to 0. How are you going to do that? Minus this T. Also put it underneath those. Minus the 5. Now I have 0 equals. What's that right-hand side going to look like now? Plus 5T. Plus 4. Okay, so I know I got William, sometimes Ray, sometimes Autumn with me. How are the rest of you guys doing? You doing okay? All right, well, it's equal to 0, so now I got to factor it. Does it have a GCF? Can I take anything out of all of those? So now I got to make 2 binomials. Is this going to be the long way or the short way? Because this starts with a 1, what can I start with in here? T's. What do I need factors of? Factors of 4 that will add to 5. 4 times 1. If we are adding, does that mean same or different? Same, and they both need to be adding. So now I'm ready for my answers. What kind of answer will I get out of this first parenthesis? And minus 1. Everybody doing all right? Now they're both not going to work, are they? I got to check for the extraneous solution. Which one you want to check first? Negative 1? Okay. If I put a negative 1 up here, what's negative 1 plus 5? 4. What's the square root of 4? 2. So this side over here is a 2. If I put a negative 1 in over there, what's negative 1 plus 3? 2. Does 2 equal 2? So this looks like the one that's going to be working. Is that all right? Can I show you why this other one doesn't work? If I put a -4 up there, -4 plus 5 is 1. What's the square root of 1? 1. Okay, so this side over here is 1. Other side, if you put a -4 in there, what's -4 plus 3? -1. Does 1 equal -1? No, so this one does not work. Questions, folks? Yeah, you can open as many as you want, and I think it's humid up in here. Everybody good? Try another one? Yes? Number 3. Do you have anything outside of those radicals that needs to be moved? I see a head shake from James. How about the rest of you? You're all good? Okay, how do I get rid of the radical? Square it, which means over here, I'm going to need to square it. Now, when we square the radical, the right-hand side is the easy side this time, folks, because the radical disappears. You see how it's the other side now that we're dealing with? How do I square x minus 3? Okay, now that I wrote it twice, can you please cut it in half for me? Okay. Distribute. Put them together, and you get a minus 6x in the middle. Don't forget to drop the other side down. Any issues so far? No? What do you need to do next? What's that? Nope, I can't do that because I have an x squared and an x. I'm going to move everything to the other side. He's trying to get this equal to 0. So I'm going to minus this x with those x's, and I'm going to add this 1 with this 9. So these cancel, and I get a 0 over here, which is what I want to do, right, folks? Set it equal to 0. James, you need to stand here for me, buddy? What do you get on this left-hand side? Plus 10. Okay, now I'm ready to factor. You got a GCF at all in here we can take out? No? Long way or short way? Thank goodness. What am I going to start with? Factors of 10 that add to 7, which is 5 times 2. If we are adding, does that mean same or different? Same, and they're going to be negative. That's only if they're different. You're thinking there. Okay, what kind of answers do we get here? 5 and 2. Which one you want to check? Check the 5 first. If I put a 5 up here, what's 5 minus 3? 2. So this side over here is a 2. What if I put the 5 over there? What's 5 minus 1? 4. What's the square root of 4? 2. So does 2 equal 2? So it looks like this one works. Are we all good with just crossing out the other answer? Okay. Only one of them can work, folks. Can I tell you why? Because if you want to have 2 answers, don't you have to have a power of 2 in the original problem? Do you have a power of 2 in the original problem? Can't have 2 answers. Number 4. You got anything outside of that radical that needs to be moved? Nope, don't think so. So what are you going to do? Square both sides. This side and that side. This left-hand side's a binomial. How do you square a binomial? What happens to the right side? Just loses the radical. Everything else stays the same. Okay, now that I've got that written twice, can you cut it in half for me? And distribute. What will it look like? Whoops, that's not right. There's no 5 in there. Or no x in there, excuse me. All right, how's that looking, folks? We didn't forget how to do that. We've done it so many times. I hope you didn't forget, right? Distribute for me. Okay. Does everybody see why it's positive? Negative times a negative? Yeah? What do you get in the middle here? Negative 10x. Nobody's going to think that the minus 5 and the minus 5 cancels, right? They have to be opposites. One would have to be positive, one would have to be negative for them to cancel. And I'm going to drop down the other side. Okay. Can I just isolate here? Can I just try and get the x by itself? No. Why? I got to make it equal to 0 because I got an x squared and an x. If this wasn't here, go for it. Just isolate. Okay? So I got to move these over here. How do I do that? Make sure that you write them underneath the terms that they are alike. So these cancel. I get a 0 over here. What's the new left-hand side? No. Okay. Do I have a GCF? No. Long way or short way? Starting with factors of that will add to, okay. 7 times 5 will not make 13. 3 times 10. If we are adding, does that mean same or different? Same. And they both need to be. Okay. Now I'm ready for my answers. What do I get from this one over here? All right. Which one you want to check? The 10? If you put a 10 up there, what's 10 minus 5? 5. So this left-hand side is a 5. If I put a 10 over there, what's 3 times 10? 30 minus 5, square root of 25, is 5 equal to 5. So that is the good one. That is the bad one. Questions? No? You sure? All right. Let's do one that's a little bit easier. How about that? Sound like a plan? Next one is a little bit easier. Do you have anything outside of the radical that needs to be moved? No? So how are you going to get rid of the radical? Square it. Now notice, that's not a binomial over there anymore, is it? No. So what is n squared? N squared. So this side is just n squared, and this side just gets the radical taken off of it. That's not too bad, right? Can I just isolate, or do I need to set it to 0? Set it to 0 because I got n squared and n. Now, I want you to stop for a minute because you might want to just move this one over here, correct? When you do that, you need to subtract it. Are we clear on that? Does that go with anything over here? No. And in fact, I want it to go first because that's the order we like our trinomials to be in, right? Now, you see how that starts with a negative, don't you? I don't like it. I'm going to take out a GCF of -1. So if I divide everything by -1, that means I put a -1 out front. What happens to all the signs on those if I divide them by -1? They just flip signs. So this is now going to be positive n squared. That'll be a -2n. That'll be a -3. And then we have my 0. Is that okay for everybody? Okay, let's factor this now. 2 binomials, starting with factors of 3 that subtract to 2. 3 times 1, perfect. Now, since we are subtracting, does that mean same or different? Different, and the bigger one needs to be negative. So that means the 3 is negative and the 1 is positive. Now, ladies and gentlemen, does this GCF of -1 get you an answer out here? No, because there's no variable there, right? What kind of answer do I get here? And what kind of answer do I get over here? Good. Which one you want to try? -1? Okay. If I put a -1 up here, what's 2 times -1? -2 plus 3. Positive 1. What's the square root of 1? 1. Okay, so this left-hand side is a 1. What is negative 1 squared? I bet you didn't put it in parentheses. If you want to square negative 1, it's got to look like that. And you get 1. Is 1 equal to 1? So this one works, which means, uh-oh, did I mess something up? Good question. When I put this negative 1 right here, I'm going to need to back up a little bit. When I put this negative 1, it's supposed to go into the original problem, isn't it? Does that original problem have a squared on it? No, that's something I wrote in to solve it, didn't I? So this would actually be 1 equals negative 1. Does 1 equal negative 1? No. So, moral of the story is, make sure you're plugging into the original and not paying attention to stuff that you did to solve it. Thank you. Questions there, folks? Everybody's okay? All right, I would like to go to number 7, please. Number 7. Got anything outside the radical we need to get rid of? Just got to get rid of the radical, right? By doing what? That's a binomial over there this time, which means the left side is just going to lose the radical. The right side needs to be written twice. Why don't you guys go ahead and cut it in half and distribute? Okay. After you distribute, make sure you combine your like terms, please. And stop there after you've combined your like terms. How'd you do? Did you get a 2a in the middle? Can I isolate this, or do I need to set it to 0? To 0 because I got a squared and a. How are you going to set it to 0? Make sure you put them under their like terms. I get 0 equals what? Okay, you got a GCF you can take out of there. Nothing besides 1, right? Okay, so what are we going to start with? Factors of that add to 4. 7. The only factors of 7 are 7 and 1, right? Do 7 and 1 subtract to 4? Sorry, they don't add to 4 either, do they? No. There's no answer here because this is not factorable. There is no solution to this problem. It does not factor. Everybody okay with that? We're ready to go back and do the squared ones? No? You'll be all right. Let's do number 8. Got anything outside the radical you got to get rid of? So what are you going to do? Good news. That's not a binomial. So what's a squared? Okay. The other side just loses its radical. Now what? Yeah, I want to get it to 0, don't I? So what's your new equation? Okay. Then what? Can I isolate or do I need a factor? Why can we isolate? Yeah, it's only a squared, isn't it, guys? So I don't have like a squared and a, do I? So all you gotta do is isolate here. How are you gonna isolate the a? Good. Everybody good with adding the 121? Do y'all see what Shane is doing, or are you just kind of letting him go here? You see it? So what's the new equation? So now how do I get rid of the squared? I'm going to square root it. What's the square root of 121? Just 11? It's plus or minus 11. Plus or minus 11. Everybody all right there? You sure? 2 answers? Negative 11 plus 11? Sounds good to me. All righty. One more. Call it a day. What do you want to do? Square them? Now, remember, that whole thing's getting squared, right? But it's a monomial. I don't need to write it twice, but I got to square both things inside of there. So what's 2 squared? And what's x squared? And this side just loses the radical. What's that? Just losing that. Yep. All right. Now what? Yep. You got it. Minus the 4x squared. So what's the new equation? So isolate or factor? Isolate. Add the 9 over. So x squared is... Nope. Just 9. When you square root it is when we do the plus or minus. How we doing, folks? Great. That's your last set of notes. Tomorrow we just got review. Tomorrow and Thursday. There's your homework.